This is part 2 of a 3-part series looking at dividing fractions, fractions divided by fractions, building from where students start in 5th grade to now 6th grade, dividing fractions by fractions, dividing mixed numbers, fractions greater than 1, and anything that can be written in this form. So dividing fractions by fractions, where we are thinking quotatively and also using common denominators along the way. And like I said, this is part 2. We're going to be looking at mixed number quotients. Part 1, we looked just at whole number quotients. So if you haven't seen that one, make sure you check out the video on whole number quotients before watching this part 2 of 3, where we look at mixed number quotients. So 5/8 divided by 1/2. Again, this strategy of thinking quotatively, we ask ourselves this question. This is how we interpret when we think quotatively. I want to know how many 1/2s are in 5/8. That's the question we're asking. And to answer that question, we're going to visualize it and show a bar model so that we can see how many 1/2s are inside of 5/8. So we'll start with 5/8. When I draw eighths, I like to start with halves and then fourths and then go to eighths. Just make sure everything is nice and even. So I'm going to show 5/8. All right, so there's our 5/8, and I need to find out how many 1/2s are in 5/8. I want to make sure that I line this up well. So in my top bar, my 1/2 was here, so there's my 1/2. All right, so now we can ask that question, how many 1/2s are in 5/8? Then I can already see there's at least one. I do have one whole half in the 5/8, but I got a little bit left over. I have this leftover piece. And to figure out how to represent that leftover piece, just like when we were thinking about whole number quotients, it's going to be a little easier to see and to interpret if both of these are broken into or partitioned into the same number of pieces. So instead of thinking of this as halves now, I want to also think of this one as eighths. So now I'm thinking, instead of 5/8 divided by a half, I'm thinking 5/8 divided by 4/8, because I had 4 pieces in this that we already knew was 1/2. So we had 4 of them in there. That's our 1. So we do have at least 1. So this is 1 and a little bit left over. But how much left over? Well, there's 1 piece. So I know my numerator, I have 1 part. My numerator is going to be 1. But what about my denominator? And when I think about what denominators tell me how many pieces are in the whole. And you might think that this is going to be 8 because if I look at the whole bar, it's broken into eighths. But our whole was actually represented here because this was our 1. There's a whole half right here. Now this is broken into 1, 2, 3, 4 pieces. And so since I have 1 left over, but I needed 4 to have another whole, my denominator is going to be 4. So 5/8 divided by a half. How many halves are in 5/8? Well, there's 1 and then a fourth of a half in 5/8. So 5/8 divided by a half is 1 and 1/4. Again, just like the last ones we did with whole number quotients, being very intentional about the choice of fractions chosen here. Moving from whole number to mixed number is a nice sequence, and also making sure that while students are still learning and developing reasoning, that we're using denominators that play well together. If I had something like fifths and eighths, I would be trying to partition these bars into 40 pieces, and that's just not reasonable if we're drawing that out. So making sure we're also picking denominators that play well together. So this next one is another great candidate for this strategy. The denominators play well, and I know I'm going to have a mixed number quotient, so that would fall sort of in this order in the sequence. So again, my question is, how many 1/4s are in 2/3? how many 1/4 are in 2/3. So I'll start with 2/3. I'm going to partition this into thirds. And actually, I'm going to go ahead and go a step further, because by now, I've done this with a lot of whole numbers. I've done this with a lot of mixed numbers. Something I've started to generalize and see is this is a little easier to think about when I start with, I'm ultimately going to get to common denominators. So I'm going to go ahead and start with common denominators now. And I know my common denominator, sort of an easy one to get to and think about. In this case, it's also the least common denominator, is 12. The equivalent fraction of 2/3 is 8/12 and 3/12. So we're going to think about this instead as 8/12 divided by 3/12. So instead of breaking this into thirds, I'll go ahead and go into 12ths. From thirds, I know if I break each of these into 4 pieces, that will give me 12ths. If I had started this thinking 12ths before I drew the thirds, maybe I would have drawn 4ths first and then broke each of the 4ths into thirds. But either way, I've got a bar with 12 even pieces here. So I'm going to draw my second bar as well to show my 1/4, or my now 3/12. So I'll go ahead and partition these, make sure everything is even and lined up. Again, I referenced in the last video, there's a great digital virtual tool on GeoGebra that does this for you, getting into 12ths. That's a lot of denominators, a lot of partitioning. Anything higher is not very reasonable to draw. And so there's a great tool on GeoGebra. I'll link it in this video as well. That can help see these without having to draw them every single time. So we've got 8/12. So there's 2, 4, 6, 8. So there we go. So here's our 8/12. And then we want to know how many 3/12 are inside of that. So I'm going to draw sort of another line or a box around that. I want to see how many of these inside this green box, how many of those 3/12 are in 8/12. So here's 1. There's 2. And then I don't have enough to make a third one. So this is going to be equal to 2 and then a little bit left over. So now we just have to figure out what's left over. There are 2 pieces left over. And then to figure out my denominator, how many did I need to make another new piece? In each of them, there were 3. Right? There were 3 in here, there were 3 in here. So I needed 3 more. So this is going to be 2 and 2/3. 2 and 2/3. There are 2 and 2/3, 1/4 inside of 2/3. So 2/3 divided by 1/4 is 2 and 2/3. So again, this is that second piece in the sequence. This is the second video. We started with whole number quotients. Now our thinking is getting a little more sophisticated with the mixed number quotients. We have our whole pieces, but then we have to figure out what's left over. How much do we have and how much do we need to make another new piece? And in part 3, we're going to look at quotients that are less than 1. So how we interpret asking that question. And that's maybe the most strange or complex question sort of in this series, as we're trying to figure out how much of one fraction is inside of another when there's not even one whole piece in there. And so that's why that's last in the sequence that I would encourage for instruction as well as these videos. So we'll see you in video number 3.